Hello, you guys. Let's talk about greatest common factor today. So let's take a look at the vocabulary here. Common factor. All right, let's say I had the numbers 27 and 45. And let's go ahead and make the T-chart to find all the factors of 27. Remember, it would be 1 times 27. 2 wouldn't work, so I'd cross it out. 3 times 9. 4 wouldn't work, so I'd cross it out. 5 doesn't work, so I cross it out. 6 doesn't work, so I crossed it out. Remember, I stopped at 6 because 6 times 6 is 36, and that's bigger than the number 27. So for 27, it's 1, 3, 9, and 27. Take a look at 45. I made my T-chart, and I got 1 and 45. 2 didn't work, so I crossed it out. 3 times 15 works. 4 did not work, so I crossed it out. 5 times 9 works. 6 did not work, so I crossed it out. And 7 did not work. And I could stop at 7 because 7 times 7 is 49, and that's bigger than 45. Okay, and now I circled all the common factors. So when they ask for the common factors, I would have to say 1 is in common, 3 is in common, and 9 is in common. Okay, now greatest common factor, I'm going to use GCF a lot, of this situation would have to be, if I were comparing 27 and 45, I would say, well, the greatest common factor was 9. They had 3 factors in common, but the greatest, the biggest number was 9. All right, but let's take a look at an example here. Let's say, and I'm going to call this the birthday cake method. We're going to use this a lot for greatest common factor and LCM. So I could have put the number 27 and 45, and then you do an upside down division. And then you just ask yourself, what's any number you could think of that goes into both of those numbers? And let's say I put 3. So I would divide both of these numbers by 3. 27 divided by 3 leaves me 9. 45 divided by 3 leaves me 15. And then I would look at 9 and 15 and say, oh, 3 goes into both of those. So I'd do the upside down division, and I'd put a 3 on the outside and divide. 9 divided by 3 would leave me with 3. 15 divided by 3 would leave me with 5. And now the greatest common factor is right here. It's all the numbers going up and down. We just have to multiply them. So the greatest common factor would be 3 times 3, which would be 9. Okay, now relatively prime is a new vocabulary word, and that's just when you're comparing two numbers and the greatest common factor is 1. So that means the only number that would go into both of them is 1. And here's a great example. Let's say I wanted to find the greatest common factor of 8 and 15. Well, I would make prime factor trees just to make sure I didn't forget about anything. So if I made a prime factor tree for 8, I would get 2 times 2 times 2, and a prime factor tree for 15 would be 3 times 5. And notice how the trees have nothing in common. When they have nothing in common, that's telling you that the greatest common factor of those numbers is just 1, because 1 goes into every number. And anytime that happens, we say that the numbers are relatively prime. And so you'll see me use an RP. Okay, so take a look at this checkpoint. Find the greatest common factor, the GCF, of the numbers, 54 and 81. So I wrote 54 and 81, and then I did my upside down division. Now, I knew 9 went into both of those numbers because 5 plus 4 is 9, and 8 plus 1 is 9, so I knew 9 would work. So I divided by 9. 54 divided by 9 left me with 6, and 81 divided by 9 leaves me with 9. And now I'm just looking at the 6 and the 9 only, and I do the upside down division, and I put the 3 on the outside because I know 3 goes into 6 and into 9. So then I divide. 6 divided by 3 leaves me 2, 9 divided by 3 leaves me 3. Now when I get to the 2 and the 3, nothing goes into them except 1, and that's how I know I'm done with the birthday cake method. So then I just look straight up and down. That's where my GCF is. And so I wrote GCF equals, and then you just multiply the numbers that are outside. 9 times 3 would give me 27. So the greatest common factor of 54 and 81 is 27. Take a look at number 2. Here's the cool part. It works for 3 numbers as well. Let's say I wanted to find the greatest common factor of 12, 48, and 66. So I just listed those numbers, and then I said, okay, I know 6 goes into all 3 of them. So I did my upside down division. 12 divided by 6 left me with 2. 48 divided by 6 leaves me with 8. 66 divided by 6 leaves me 11. Now when I look at the 2 and the 8 and the 11, nothing goes into all three. Remember, it has to go into all three. Nothing goes into all three except 1. So that's when you know you're done. And so you just take a look here. So the GCF is staring at you. It would just be 6 for all of these numbers. Okay, let's talk about example 2. Sorry, our dog is going crazy. Identifying relatively prime numbers. So first we're going to find the greatest common factor, and then we're going to tell whether the numbers are relatively prime. So take a look at A. They want us to look at 28 and 63. So I wrote 28 and 63, and I did the upside down division. Now I knew that 7 went into both of the numbers, so I put 7 on the outside and I divided. 28 divided by 7 left me with 4. 63 divided by 7 leaves me with 9. Now with 4 and 9, nothing goes into both of them except 1, so I knew I was done. So remember, the greatest common factor is staring at me. The greatest common factor is 7, and because it's 7, these are not relatively prime. Okay, so I boxed my answer. Take a look at B. They want us to compare 42 and 55. So this time I'm showing you how you can use the trees to help you. So if I did a tree, a prime factor tree for 42, I broke it apart as 6 times 7 and I circled the 7, and then I broke apart 6 as 2 times 3 and I circled the 2 and circled the 3. With 55 I broke it apart to be 5 times 11. Now notice, in both of the trees, there is no number that they have in common. Nothing matches. So when that happens, you know the greatest common factor of both of those numbers is 1, and so it is relatively prime. And you can just put RP. Hello, you guys. Okay, I'm going to try to do this even though my dog here, I'll show you, this is my doggie right now. She's wanting me to play with her, and so if you hear her snorting in the background, that's what's going on. Okay, so take a look at the checkpoint. Find the greatest common factor of the numbers. Tell whether the numbers are relatively prime. Take a look at 3. So 30 and 49. Since I couldn't think of something right away that went into both, that's when I'm going to do prime factor trees. So I broke apart 30 to be 2 times 3 times 5, and I broke apart 49 to be 7 times 7. When I compared the trees, they have nothing in common. Nothing matches, so the greatest common factor is 1, and so they're relatively prime. Take a look at number 4. 52 and 78. I went ahead and set up the birthday cake method because I saw they were both even, so I knew 2 would go into both. So I put 2 on the outside and then I divided. 52 divided by 2 is 26, and 78 divided by 2 is 39. And then with 26 and 39, I knew 13 went into both, so I went ahead and divided by 13. 26 divided by 13 left me with 2. 39 divided by 13 would leave me with 3. And so when I got to 2 and 3, I knew nothing would go into those except 1, so I was done. So my greatest common factor is right here. I brought it down. Greatest common factor is 2 times 13, which is 26. So these numbers are not relatively prime. Okay, take a look at example 3, finding the GCF of monomials. Well, this is really cool. Okay, just remember to write the variables out in expanded form. So if I wrote 16x squared y, I wrote 16x times y. And for 26x squared y cubed, I wrote 26 times x times y times y times y. Okay, start with the numbers, the coefficients. Look at the 16 and the 26. I knew 2 went into both, so I divided. 16 divided by 2 left me with 8, and I brought down all the variables. 26 divided by 2 gave me 13, and I brought down all the variables. Okay, now on the next step, since you know you're done with 8 and 13, nothing goes into them except 1, I want you to use your red and just look at what matches. See how they both have 2 x's and a y in common. So I circle what they have in common and I bring it out here. 2 x's and a y come out to the greatest common factor column. Okay, and then I drop down everything else that I didn't circle. So I drop the 8 down, I drop the 13 down, and I drop the 2 y's down. And you always want to check this bottom layer to make sure that you didn't forget anything. But there's nothing else that these two monomials have in common, so I'm finished. So my greatest common factor is everything in the tower, everything going up and down. So the GCF is 2 times x times y, which I can write as 2x squared y. All right, so take a look at this checkpoint. Find the greatest common factor of the monomials. So I wrote 12x cubed as 12 times x times x times x, and 18x squared as 18 times x times x. Now remember, start with the coefficients and numbers. Take a look at 12 and 18, and I saw 6 went into both of them, so I put 6 on the outside and I divided. 12 divided by 6 left me with 2, and I brought down all the x's. 18 divided by 6 leaves me with 3, and I brought down the x's. And now just double check the numbers. The 2 and the 3, you know you're done because the only thing that goes into them is 1. So you can start looking at what matches as far as the variables go. And see how they both have 2 x's in common? So I circled the two x's that they have in common, and I brought that outside. X times x is what matches. And then look at what I brought down. I let the 2 come straight down, I let the x come straight down, and the 3 came straight down. So look at this bottom layer. This is important that you see that they have nothing else in common. So then the greatest common factor is just everything here in the tower would be 6 times x, which is 6x squared. Okay, take a look at number 6. So I wrote 40xy cubed as 40 times x times y times y times y, and 24xy as 24 times x times y. Starting with the coefficients, the numbers, I put a 4 on the outside and I divided. 40 divided by 4 left me with 10, and then I brought down the x and the y's. 24 divided by 4 left me with 6, and I brought down the x and the y. With 10 and 6, I divided by 2, and so 10 divided by 2 left me with 5, and I brought down all the variables. 6 divided by 2 left me with 3, and I brought down the x and the y. And since I was done with the numbers, the 5 and the 3, I looked at the variables and I circled everything that matches. So they both have an x and a y, so I circled it and I brought it to the outside here. And then I dropped down everything that I didn't circle. So I dropped down the 5, I dropped down 2 of the y's, and I dropped down the 3. Now remember, you have to get in the habit of looking down at the last layer of your birthday cake and making sure that nothing else is in common. And so we're done. So then you grab everything in the tower, and that's your greatest common factor. So the greatest common factor is 4 times 2 times x times y, which would be 8xy.